What I'm going to be talking to you about today is a project where we got some farmers and some researchers together in a group to measure some Ontario pastures. And we measured things like biomass, basic livestock details, and soil health. This was an interdisciplinary project in that it was an intercommodity project. So, as you can see here, I have a photo of dairy cows on pasture. And this project included beef, sheep, and dairy commodities. So I'm going to be talking about all three, even though I know you might be more interested in the beef particularly. So why did we start this project in the first place? Pasture systems, which we might consider to be a sustainable livestock grazing option, need to be profitable to be kept in the landscape. And in many places in the world that have many temperate pasture acres, places like Ireland and New Zealand, they have things like yield targets, they have pasture quality monitoring throughout the year, and they have residual or exit height targets. Um, in Ontario, we don't have any on-farm pasture measurements that we can use to make these recommendations. So we are kind of at a lack of being able to provide this type of advice to our pasture producers. And to be able to get some of this benchmarking data to be able to start making these grazing recommendations, we set out to do a project. And in this project, we picked this particular tool, which is called a rising plate meter. And we picked it because it's a very simple way of measuring forage biomass. And you can measure a pasture in the time it takes to walk across it. It takes both a height and a density metric into account, and it allows you to convert this height and density into a kilogram of dry matter per hectare with a conversion formula. And I just have a photo here of me holding the rising plate meter, so you might have a better idea of how it might work. So the red piece is going to slide up that notched bit of metal. And this sliding will happen as the plate is pushed up by the forage underneath of it. Now, this tool is great, but it needs calibration for Ontario pastures because it's typically used in other places with other species under other environmental conditions. So we need something specific for Ontario pastures. And that was one of the things we set out to do in this project. Now, our sampling sites for this project, we had a lot of them, and our sample sites were selected based on volunteer participation. And um, these volunteers had several things in common. One was an above average interest in grazing, and they all had some type of rotational grazing, strip grazing, some other type of rotational pasture management. Now, we did have these three categories, as I mentioned before. We had the sheep, the beef, and the dairy operations, and these are highlighted on the map. You can see there is a bit of spatial separation. We had a lot of our sheep farms were more towards the east, and then more of our dairy farms were a little bit more central and then south and west. And then our beef farms are kind of scattered, but not in the east. So we had a little bit of that spatial variation there. We also did have some additional research farm sites. We did some sampling at the Ontario um, Beef Center in Elora. And there were also a few community pastures that were part of this group as well. And we even had some producers who raised both beef and sheep on pasture. So for this project, researchers took some samples on the farms, but we also had our farmers collect their own data. So what we asked our farmer participants to do was to sample or pick to sample three paddocks or field strips on each of their farms. And these would be measured before and after each grazing event. And we asked our farmers to pick pastures that they felt that they could get 3 rotations a year on. Whether or not this happened is obviously very weather dependent, but it sort of regulated the pasture selection for pastures that had the yield potential to be able to do that, or they were good, relatively good land or relatively good pastures to begin with, just so we could get a more robust set of data that was kind of ideal pasture production in Ontario. Now, we asked these farmers to put their pasture and livestock data into a Survey 123 platform where they submitted it to us, and we were sent a report on the data that they submitted. In return, farmers received individual production reports during the season every time they submitted data, and they also received a stipend for their participation at the end of the year. This happened for several years. This project has been going on for several years, but this particular set of data with the 3 paddocks or field strips was collected in 2 years, 2024 and now 2025 as well. The other component of the group was we facilitated ways that farmers could interact with each other. This included monthly online meetings. These meetings were facilitated by our very lovely forage and grazing specialist, Christine O'Reilly, and the farmers were able to choose their own discussion topics. We also had in-person pasture walks and farm tours. This typically was 3 tours or 3 meetings per year in person. And we hosted 1 meeting on either side of Toronto every time we hosted a meeting, because Ontario is super big. No one wants to drive across Toronto. So we also had a WhatsApp group, which the farmers could interact continuously with each other, and researchers were also included in this WhatsApp group. The WhatsApp group kind of took on a life of its own and allowed us to see that learning often happens organically in these groups, and I think it really provided an opportunity for everyone to learn from each other. We did actually have a lot of success in this project. Um, we were able, as researchers, to go out and conduct over 150 sampling visits to these research farms and research sites, and this represented over 2,000 calibration points. So, making a calibration will hopefully be robust and Ontario-based and allow us to look at individual regions in Ontario. Our farmers also did really well in inputting the data that they collected on their 3 fields that they were measuring. We received 819 Survey 123 entries, which ultimately represented 360 grazing events. Now, the grazing events would consist of 2 entries, one before grazing and one after grazing entry. So that's why the grazing event amount is a little less than half of the total number of entries we received. We also did some soil testing on 22 of the farms that participated in the project, and this represented about 60 soil health samples. Several farms received more than one sample, depending on where they were measuring their own 3 fields. We tried to pair soil samples to be able to look at the soil that was on those paddocks and compare that to the production data that the farmers were giving us. So, one thing I wanted to touch on was what we learned about running a farmer data collection project. And one thing that was really successful in recruiting participants was we used a clear job ad for our farmer participants in order to attract them to the project. We told them what we expected of them and asked if anybody would be interested. And then we sort of screened the responses we got for that, above average interest in grazing, rotational grazing, and we tried to balance the amount of different commodities we had. So it was split relatively evenly between beef, sheep, and dairy. We tried. The other thing was to try to keep farmer data collection as easy as possible. Researchers are busy, but farmers are even busier. So This is a screenshot of what your cell phone might look like if you opened Survey 123 and you were going to enter data for us. So you would be able to select your farm name and then select your paddock name, one of those three paddocks that you had agreed to measure. Then you could draw the paddock. Now, this was important because if our farmers were doing some strip grazing, the strips might change size depending on the time of year or how much forage the farmers had decided to allocate to their farmers. And we also then started to ask them about what type of data collection they were entering. So is it pre-grazing? Is it post-grazing? Is it something else? Did they cut with a mower? Like did they take the field for hay instead of grazing it? We wanted to know that too. And so there was a number of other questions, but they were very simple, straightforward. Click the button, enter the data, keep going. Um, we also made sure to emphasize involvement flexibility. So not everybody participated in the WhatsApp group, not everybody came to every meeting, and that was totally okay with us. It was, as much involvement as each farmer wanted to have. Some people really like to chat, really like to socialize. Some people really don't. So that was totally fine. The other thing is that we didn't actually receive all of our data during the grazing season or as it was happening. We understand that sometimes you just needed to write it down and keep on going. So um, we checked in with our farmers to get the data at the end of the year, but we weren't in a rush to collect it. So some of it we received, just only a few months ago. Now, I'm going to get into a few results that we actually found in this project. One of them is, I think, maybe what everyone wants to know, including me, is actually developing the rising plate meter calibration. And what is this calibration going to be? How do we convert this rising plate meter measurement into an Ontario biomass measurement? And I very much wish I could tell you that at this time. Um, but I can tell you that we're working with data that's, been collected since starting in 2021. We've got lots of data. We're looking at determining whether or not we need different calibrations, different math for different regions, different times of the year, and also different commodity types. And those results will be coming out fairly soon, although um, being, I would be lying if I could give you a specific date in which we were going to be able to tell you those things, but I do promise I'm working on it. Um, the other thing that I wanted to talk about in terms of results was that some of the first things we noticed was that our beef, dairy, and sheep operations look different from each other. And that seems maybe obvious, but it did show up in the way our farmers were measuring, in the way they were managing. And so I just wanted to talk briefly about it. For our sheep producers, sheep, they graze differently than cattle and they graze tight to the ground. Sheep pasture managers are also managing often for parasites. And so this results in a different pasture management than something with cattle. With our cattle, for beef, often we had our farmers monitoring and managing for quantity, and our dairy producers were more focused on quality because their milk production depends on the quality of feed that those dairy cows are receiving. Now, what we had kind of thought is that these things would show up in our rising plate meter data. And they didn't show up as much as we thought they were going to. And so the question is why? And we can answer that question a little bit because with the rising plate meter, when the rising plate meter is measuring a short grass, so maybe something that has been grazed maybe 2 or 3 weeks ago and is growing back and is kind of at that maybe like 10 to 20 centimeter stage, the rising plate meter is very easily able to rest on top of that forage. If you start to have your pasture that has taller grass that potentially is going to head, or is just quite tall. I know walking through pastures, I'm not a particularly tall lady, and when I walk through pastures in mid-June, end of June, they're, up to my waist. Um, and that is something that the rising plate meter can't really handle because it cannot reach tall enough to be able to get on top of that grass. So it's too tall to be able to plate. And because some of our farmers were growing pastures that were too tall to plate, this did influence our data quite a bit. And it also told us some things about what the rising plate meter is good at measuring, what kind of production it's good at measuring, and what it can't do. So now I'm just going to show you a few graphs. And these graphs are things that are from our farmer collected data. So the first graph that I am sharing with you is one about rest period. And this graph has rest period on the y-axis, and it has month on the x-axis. And rest period would be the amount of days in between grazing events. The red line is actually a typical recommended resting period for Ireland, for Irish pastures. And this is typically lower than 30 days or about 30 days. And as you can see, the actual rest periods that we measured for Ontario pastures were often longer than the 30 days that might be recommended in a place like Ireland, and they got longer over the season. And this has to do with the way our grass grows and also the moisture availability during the summer season, where you might need a longer rest period time in order for that grass to recover and grow back. Now, there weren't any statistically significant differences between the different commodities here, but there were some numerical differences. So, just for your interest, I will tell you. For our beef producers, the average rest day over the whole season was 44 days in between grazing events. For dairy, it was 41, only a little bit shorter. And then for sheep, it was actually a bit longer at 50 days on average. The next slide I want to share with you is some information about yield. So dry matter, kilogram per hectare biomass. And we were looking at yield in each rotation that the paddocks received. Now, most of our paddocks were able to capture 3 rotations. Some of them even captured 4 and 5 rotations. In fact, we had one data point for a 6th rotation, but because there was only one data point, it's not included in this graph. And the rotations are listed on the bottom here. So, what we know about hay production lines up with what we see here. Our first rotation or your first cut of hay is always going to be your highest, and then your subsequent rotations will yield less. Now, we measured in both 2024 and 2025, and in a lot of the province, 2025 was a much drier year, but actually, we didn't see that in the data. The rotation yields that we got were similar, and statistically, there were no differences. And this might be attributed to the fact that it was so dry in some parts that the paddocks weren't even grazed and therefore not measured, so therefore, we don't have that data. Or alternatively, that the farmers waited long enough for them to recover, and therefore um, we saw the same amount of yield, even though it took potentially longer. And I did test that in terms of our rest period, our blue graph that we just saw, for rest period between 2024 and 2025. And our average rest period between 2024 and 2025 was only 4 days longer for 2025. So that may have not been the case, but we had a very wide variety of farmers in the group, and we also had a wide spatial differentiation. So, in more of the west of Ontario, it wasn't nearly as dry as it was in the east. One thing that I wanted to mention, getting back to this yield graph, was that It was our dairy farmers that saw the fourth and the fifth rotations, particularly the fifth. Only dairy farmers, the only fifth rotation data we have is from dairy farmers. And then we actually don't have any fourth rotation data for our sheep farmers. So this does represent a difference in management, but it is a bit difficult to capture in our yield by rotation data. And this is just a faceted graph showing each box is one rotation and it's split between our beef in red, our dairy in green, and our sheep in blue. So as you can see, there's no red and blue boxes in the fifth rotation box because we didn't have any data from our beef and sheep producers because they didn't conduct a fifth rotation on the pastures that they were measuring. The last graph I have to share with you tonight is a utilization graph. So this is the amount of forage consumed by the livestock while they are on that particular pasture. And this is split out by rotation. Um, so on the y-axis, it's the utilization percentage, and the x-axis splits it into each one of those 1 to 5 rotations. Now, the red line is again a recommendation from Ireland, and this is about 70% utilization. This really varies depending on the commodity that is being discussed. Anywhere between 60 and 80% is recommended depending on what kind of livestock we're talking about, but on average, it's about 70%. Now, our farmers did, for the most part, achieve this recommendation, even though it's not even a recommendation for our country. Um, but what we did find is that this utilization kind of has a pattern where it increases just a little bit, but not significantly. And then our fifth rotation, the utilization is a little bit lower. Um, and this could be potentially the way the rising plate meter is measuring, or potentially the ability for animals to graze past any dry stubble that is there by the fifth rotation of the season. And so I just want to wrap up by talking about a few next steps that we are going to be working on in the project. We have all the data at this point, but we're not done wrapping up with our farmer participants, finding out how they found the project and their takeaways ultimately from the project and from the rising plate meter. We are also going to be, of course, working on the final or working calibration. And so I just wanted to say, watch out for more data coming from this project because we are definitely diving in very deep with this data and trying to figure out what we can tell you about successful pasture production in Ontario or typical pasture production in rotationally grazed pastures in Ontario. And we're very excited to be able to share more of that with you later. Um, I also wanted to mention thanks to all of our farmers who participated and submitted all of this wonderful data that we're now working on, as well as our summer students who helped collect some of this research data, Basil, Amelia, Danny, and Isabella, and then the Forage and Service Crops lab students and staff. I did want to mention that I am the PhD candidate on this project. The PI is Dr. Kimberly Schneider, and both James Byrne and also Christine O'Reilly were the OMAFA coordinators and organized this project as well. So thank you all for listening, and I'm happy to answer any questions.